When I was younger growing up, I always wondered what it took to make an airplane fly. Obviously, being younger, you can't really understand the idea of atmosphere and that, gas is actually it was a liquid, but it's something that you can't exactly touch. So it's hard to put those things into play whenever you're younger. But as I got older, I was able to apply those kind of um, theories towards actual practicality. And getting into auto racing, which is something that I'm really involved in, it kind of got my brain turning as far as how you generate lift and you generate downforce and drag, which are the three basic principles of aerodynamics. And by definition, NASA.gov says that aerodynamics is the study of forces and resulting motion of objects through the air. Now, to get into our first principle or principles of aerodynamics, it's going to be lift. And by definition, Empower UK says that it's when air passes over a wing or any kind of object, that when the air on top has a longer distance to travel than the air on bottom of whatever object it may be, the air on top is going to have a longer path to follow, which in turn makes the airspeed of the air on top go faster, and this causes a low pressure on top, or if you're talking about downforce, it'd be on bottom. So if you're trying to create a lift like on an airplane, if you make the wing in such a fashion to where that air has to travel a longer distance to go over the top as opposed to the bottom, that's going to cause the air on top to go faster. Now that faster air is going to cause a low pressure, which will generate lift. And a perfect example of doing that is take a piece of paper. Now this is not a wing, of course, but this is the same principle that's going to be applied whenever you get an airplane that's actually moving. The air on top, if it moves faster, will lift everything because the air on top will be going faster as opposed to the air on bottom. Now, if you watch this, perfect example. The air on top was going faster than the air on bottom, causing low pressure, which causes the piece of paper to lift. Now, this is going to be applied for the airplanes because whenever you make the curvature of the airplane wing curves on top and is shallow on bottom. Therefore, whenever you get moving through, any kind of, engine, jet, or prop engine, whatever have you, the air on top will be going faster than the air on bottom, which will cause your lift. Now, on the adverse or on the opposite end of that, you have downforce, and downforce is used for basically auto racing and everyday driving. Downforce is just the opposite of lift, which by definition is the principle of lift reverse to suit road cars to stick them to the ground, basically. And this is where you see a lot of your race cars that have your big wings and the like. The reason why they have those is because it's an opposite of an airplane wing. It's actually causing the air to stick them to the road. That way they have more grip. And a lot of these cars, especially in Formula One, they generate so much downforce that if they're in a tunnel, they could actually ride on top of the ceiling of the tunnel. It's the same thing as an airplane, just sticking them to the ground. Now, in order to create downforce, obviously you have to have the wings and the like, and whenever you do such things, you cause drag. And with drag, by physics.info, they say that the force of an object that resists its motion through a fluid is called drag. Now, basically, this is an easy example of this. If I just have an ordinary folder and I try and move it this way, there's resistance. Now, the resistance is due to the fact that I'm taking a flat surface and I'm pushing it against the air. Now, if I was to turn it this way, obviously, I would have no resistance, or maybe just a minimal amount of resistance. However, this is the principle of drag. So, whenever I was getting into aerodynamics and trying to understand the basic principles, this is the one thing that kept coming up was the drag and downforce coefficient. You cannot have one without the other. And whenever you apply this to racing, which is what got me really interested in aerodynamics, it was always something that engineers was always trying to chase the best way to yield an intense amount of downforce without having the drag. Because like I said, you cannot have one without the other. And this kind of went into just to get into like the racing education of things. There's a way to create a bunch of downforce without hardly having any drag at all, and this is called the ground effect. And the ground effect is essentially forcing air underneath the car and then putting two sliding skirts on the side of the car to where the air can't be released, but that air that's being forced underneath the car causes that low pressure. And through that low pressure, obviously you generate an intense amount of downforce. So through that, and then through, just sculpting wings, and you can basically sculpt the wing in the front of the car to do certain things with the air to meet the back of the car to where you can generate more downforce. But to me, it's always been something that's been very interesting, and especially, you just see, especially as a kid, you see things flying in the air, and it just kind of makes you wonder, like, how is this possible? And to me, it's something that's always captivated me, and it's something that I hope to, in my near future, try and get a greater understanding of, and maybe apply it in some kind of field that hopefully I'll be a part of one day. Thank you.